the reaction under A plus RB, the reaction under B, both are upward, this and this, so they will be positive. So there is no other vertical force, the sum of RA plus RB equal to 0. Okay. So I call it 1. Then I write the moment equation. Sum of all the moments, let's say about point A equal to 0, positive clockwise. So if I take this equation, then first is the moment of RA will be 0 because it is passing from the same point. Then this direct movement which is acting at point C, it's a clockwise direction, so I write M. Okay. Then the moment of RB, so this is RB, right, which is acting upward. I'm taking movement about this point. So then this RB will create an anti-clockwise rotation of the beam. So it will be negative. Then RB into L equal to 0. Now from here I write the value of RB will be equal to M upon L. Okay. Now if I put this value over here, put in 1, we get RA equal to minus M upon L. Okay. So RA will be equal to minus M by L. So I write this is minus M by L and this is M by L. Okay. So this is the first step, that you determine the reactions. Now I go to second step. Formulate comprehensive law of bending moment. Okay. So for that, I must pass section in the last segment of the beam. Now the last segment of the beam is CB. Section area here and draw the free body diagram of left hand side. So first I draw the beam on left hand side of the section like this. So this is RA, which is negative, and the distance is up to cut point, the distance is X. So this distance is distance X from left hand side. Now here there will be a moment that you need to calculate. I calculate, let's say MX. I call it as MX so that you should not confuse it, the moment at C. So there's a point C as well. Now at point C, now this is point C, this is point A, this is C, and at point C there is a clockwise movement like this whose value is equal to M. Now the distance of this point C so this distance is small a, so this is X minus A. So if this is A, this is X, so then this distance from point C to the cut point is X minus A. Now I apply this equation that sum of all the moments about point X equal to 0, positive clockwise. So if I take moment about the cut point, about this point, Then first is moment of minus m by L. It is minus m by L force into distance total x. So I take this diagram with me so that it will be more clear to write the equation. So we take moment about this point. So first is moment of this minus m by L. So this is minus m by L into x. Okay. Then this direct movement, which is m, which is clockwise, so it is positive m. Then this is anti-clockwise, so minus mx equal to 0. So the equation of bending moment at any point is equal to minus m by L into x plus m. I call it equation number 2. Now step number 3. Equation of elastic curve. So if I write the equation of elastic curve, it will be like this: EI d square y upon dx square equal to minus m, let's say mx. I write x, that is the moment at any point is x. I call it 3. Now put equation 2 in 3. Put equation 2 in 3 over here, and I write EI d square y upon dx square equal to minus mx. Now multiply this whole equation with negative sign. I get m by L into x minus m. Now here, now I'm going to do very important step over here, right? I draw the, first of all, I draw the dotted line. I draw first dotted line in Macaulay's method. I write the first dotted line here after the first term. Okay, that is this term. All right. So I want that this law of bending moment should be valid for the entire beam. For that, I have to convert this equation into the standard form as per Macaulay's method. So the standard form is I multiply this m with x minus a expression raised. So this is very very important step over here because मेरे को एक standard form में लेके आना है अपनी equation को. So I multiply this m with x minus a raised power 0. This x minus a raised power 0 is equal to 1, right? So if this is 1 multiplied by m, it remains same. Okay. Now it is in standard form. Now I can go for integration. So I do first integration. So integrate EI dy by dx on this side equal to mx square upon 2l plus c1 minus m x minus a raised power 1. Okay. So x minus a raised power 0, the integration will be x minus a raised power 1 divided by 1. आप ऐसे लिख सकते हो, which remain the same value. I again integrate. If I do another integration, I get EIY on this side equal to m x cube upon 6l plus c1x plus c2, then minus m x minus a square divided by 2. So I call it 4, call it 5, and call it 6. Okay. So Equation number 4 is integrated. First, if I integrate, we get the slope. Second time integration, we get the deflection. Okay. Now, only thing is we need to determine the value of C1 and C2 by applying the boundary conditions. So, step number 4. Apply boundary conditions. So, if you apply the first boundary condition, that is at x equal to a, your deflection will be 0. So, at point A, because point A is a supported point, so deflection remains 0. And point A also lies in segment AC. Therefore, we consider equation only up to point C. C तक की equation जो है, right, up to point C. So this, up to this line of deflection equation, we put the values. So EI into Y0 equal to mx square, mx cube upon 6L plus C1 into 0 plus C2. So it means C2 will be equal to 0. Then I apply second boundary condition. I know another point at x equal to L, y will be 0. That is point B. So point B lies in segment CB. So point B lies in segment CB. So therefore, I have to take the entire equation number 6, the equation of deflection. अब सारी की सारी लेनी पड़ेगी equation, because अब C के बाद वाली equation भी मेरे को use करनी पड़ेगी, because point B lies in CB. So I write EI into 0 equal to ml cube upon 6L plus C1L plus C2 is 0. Then minus m by 2 L minus A square. So if you simplify this equation, it's equal to C1. So C1 comes out to be m upon 6L into 3b square minus L square. So C1 की वैल्यू मेरे पास आ जाएगी m by 6L 3b square minus square. So C2 is 0 and C1 is having some finite value. So I put C1 and C2 in 5 and 6 and write the final equation, which is my answer. Put C1 and C2 in 5 and 6. So I write EI dy by dx equal to mx square upon 2L plus C1 plus m upon 6L 3b square minus L square dotted line minus m x minus a. Then EIY equal to mx cube upon 6L plus C1x m upon 6L 3b square minus L square into x. C2 is 0 minus m by 2 x minus a